The application of remote sensing technique are almost unlimited. In nearly all cases, the application relate to the collation of information necessary for the planning of the future development. In land cover, land use, it is equally applicable. Almost every activity of man takes place on the land. Consequently, the knowledge of what exists where is very paramount for planning purposes. This information can be obtained from remote sensing data. Few applications are land use, land cover, agriculture and natural resource, water resources, urban and regional planning, forestry application, geology application, hydrology, sea ice, mapping, ocean and coastal monitoring. Land use, land cover applications. The knowledge of land use and land cover is important for many planning and management activities concerned with the surface of the earth. The term land cover relates to the type of feature present on the earth's surface. Urban buildings, lakes, trees are all examples of land cover types. The term land use relates to human activity associated with a specific piece of land. The remote sensing tend to orient towards application that have direct and immediate benefit to the people and society. In this regard, map types that are designed to show both natural and man-made features on which data pertinent to those aims is recorded and for which up-to-date information is easily extracted are referred to as land cover and land use maps. The satellite images and aerial photographs are good starting point for making land use or land cover maps. Satellite remote sensing is an evolving technology with the potential for contributing to studies for land cover and change detection by making global comprehensive evaluation for many environmental and human actions possible. These changes in turn influence management and policy decision making. Satellite image data enable direct observation of the land surface at repetitive intervals and therefore allows mapping of the extent and monitoring and assessment of stormwater runoff, change detection, air quality, environmental analysis, energy saving, carbon storage and avoidance, irrigated landscape mapping. From these, it is obvious that there are a variety of ways in which remote sensing can be used in land cover and land use mapping and analysis. It is particularly useful when utilized along with geographical information system, that is the GIS. Green vegetation, index soil, brightness, map vegetation, hue, that is a color, change map, sharp vegetation index, black and white, etc. Satellite remote sensing is an evolving technology with the potential for contributing to studies for land cover and change detection by making global comprehensive evaluations of many environmental and human actions possible. Sensing land use application of remote sensing include natural resource management, wildlife habitat protection, baseline mapping for GIS input, urban expansion, logistics planning for seismic, exploration, resource extraction activities, damage lineation, tornadoes, flooding, volcanic, seismic, fire, legal boundaries for tax, property evaluation, target detection and identification of land strips, roads, clearing bridges and land water interface. Agricultural and natural resource applications. Remote sensing in agriculture and natural resource management is an important promising tool. Comprehensive, reliable and timely information on agricultural resources are very much necessary for countries whose mainstay of the economy is agriculture. Agricultural survey is a backbone of planning and allocation of the limited resources to different sectors of the economy. Possible application areas include mapping of agricultural land resources using remote sensing as a guide to farmers on the right type of crops that can be grown, remote sensing application to select a tube well or land water harvesting sites, statistics for forecasting irrigation timings, harvest timings, price fluctuation, food availability and input requirement, etc. Regarding the application of remote sensing in agriculture, Kumar remarked that remote sensing in agriculture and natural resource management is an important promising tool in agricultural information and management system. Comprehensive, reliable, timely information on agricultural resources are very much necessary for the countries whose mainstay of economy is agriculture. Agricultural survey is a backbone of planning and allocation of the limited resources to different sectors of the economy. Such countries need to use this technology more and more to address various agricultural challenges including water management system, elimination of soil nutrient profile, water profiling, biotic and abiotic plant stress, crop coverage, pest condition and surveillance, deforestation, biodiversity, assessment, marine biology, etc. The potential of remote sensing technology is great and especially in conjunction with the rapid developing information and communication technology include the geographical information system for the benefit of farming communities. Studies which involve the worldwide supply and demand for agricultural products show that the application of remote sensing in general are indeed many and varied ways. Aerial photographic interpretation is useful aid in crop condition assessment. Harmful conditions can be assessed including crop disease, insect damage, plant stress from another cause and crop damage resulting from such disasters as flooding, fire, tornadoes and hurricanes. Crop yield estimation based on air photo interpretation has also met varying degrees of success. Many additional agricultural applications includes mapping of agricultural land resources using remote sensing. The current system of collecting and maintaining land records was fought with difficulties and has always been full of controversies, especially in the case maintaining proper land records. The use of remotely sensed data would ensure accuracy and transparency in this process. The use of the newly available and inexpensive handheld GPS guided mapping devices to gather local level land records. Attention is also drawn to the role of GIS mapping in this area. Data collected could be entered into real time in various layers of GIS based software for analysis. It is also used as a guide to farmers on the right type of crops that can be grown from the knowledge of the existing soil condition to get the maximum output. Other information like availability of water for irrigation and water retaining capacities of the soil could also play a vital role in the choice of crops and inputs for maximum productivity, all of which remote sensing can be applied. Remote sensing application to select a tube well and rain harvesting sites which could effectively help enhance the potential of groundwater resources. Thus, by surveying the area under agriculture for various factors like soil nutrient profile, water availability, crop status, etc., specific data could be generated for different agroclimatic zones. Planning specific cropping patterns and assessing production estimates based on the data provided would help farmers to minimize losses. To generate significant agricultural statistics for forecasting irrigation timings, harvest timings, price fluctuations, food availability and input requirement, yield determination, soil and fertility analysis, crop health, irrigated landscape mapping, studies to determine areas of soil erosion control, weed control, fencing or other remedial measures, determine of the adequacy of existing irrigation systems for uniformly wetting an entire field, farm livestock survey. Of a true remote sensing can play a vital role in agricultural studies. It helps in ascertaining the exact crop area and land use pattern, etc. The applications are many and varied. Water resource application, whether for irrigation, power generation, drinking, manufacturing or recreation, water is one of our most critical resources. Remote sensing technique can be employed in various ways to help monitor the quality, quantity and geographic distribution of this resource. For example, air photo interpretation can be in water pollution detection and flood damage estimation. Also, a knowledge of groundwater location is important for both water supply and pollution control analysis. The identification of topographic and vegetation indicators of groundwater and the determination of the location of groundwater discharge areas, that is in the springs and seeps, can assist in the location of potential well sites. Also, it is important to be able to identify the groundwater recharge zone in order to protect these areas from activities that could pollute the groundwater supply. Urban and regional planning. Urban and regional planning requires continuous acquisition of data to formulate the government policies or programs. The roles of planning agencies and establishments are becoming increasingly more complex and extend to a wide range of activities. There is an increased need for these agencies to have timely, accurate and cost effective sources of data in various forms. Remote sensing data fits clearly into this need. For such remote sensing data to serve the needs of the urban and regional planning, it must have a great resolving power. Presently, a very high resolution satellite imageries of less than 1 into 1 meter are increasingly being produced by different imaging systems and companies. The urban and regional planning requires continuous acquisition of data to formulate government policies and programs. The role of planning agencies is becoming increasingly more complex and is extended to a wide range of activities. Consequently, there is an increased need to these agencies to have timely, accurate and cost effective source of data of various forms. According to Vanga, the primary stage of making an urban planning is the survey of present situation, which requires a lot of people, material and money in the past. But with the advent of the remote sensing has been used as a new means to get the spatial and attribute information that is more speedy, accurate and economical. There are mainly two ways to do the remote sensing image classification. Population estimates, for instance, can be indirectly obtained through our photo interpretation. Air photo interpretation can also assist in house quality studies, traffic and parking studies, as well as various location and siting problems such as the transportation route location, transmission line location, etc. Specifically, the following areas of applications are common in urban and regional planning: urban infrastructure mapping, interpretation and analysis, high resolution satellite imageries used as map substitutes for visual interpretation, updating and monitoring using repetitive coverage, urban morphology, population estimation and other physical aspects of the urban environment, space use surveys in city centers, site suitability and catchment area analysis, transportation system planning and modeling urban growth or sprawl and trend analysis. Planners can apply remote sensing and geographic information technologies in all the aspects of the planning process, including the data collection and storage, data analysis and presentation, plan or policy making, communication with the public and decision makers, and plan or policy implementation and administration. From the foregoing facts, it is clear that the role of remote sensing and other information technologies cannot be overemphasized as far as urban planning is concerned. The key area of such applications have been highlighted. There is definitely much more than the remote sensing can assist in urban planning and regional planning. Forestry applications. Forestry is concerned with the management of forest for wood, forage, wildlife and recreation. However, because of the principal raw product from forest is wood, forestry is especially concerned with timber management, maintenance and improving the existing forest stands and fire control. Forests have played a central role in the economy, social and cultural development of many countries in the world. Forests were once seen solely as a frontier from which resources could be extracted, but now They are viewed as many as precious islands that serve as refuges for natural and for nature and recreation and act as a buffer against environmental degradation. This shift in value has been most noticeable in the terms of public forest. Effective management of forest resources require reliable and timely information about the status and trends of forest resources. In this regard, remote sensing and GIS play a very vital role. New forest management priorities, however, have raised the question of whether these effects characterized by the use of ground and aerial observation and by the focus on vegetation measures are evolving sufficiently to meet future information demands in terms of depth, breadth and timeliness. According to Tink, there are many forestry issues that remote sensing can be applied. Some of these applications include terrain analysis, forest management, recultivation, updating of existing forest inventories, forest cover type discrimination, the delineation of burned areas and mapping of cleared areas. Forests of one type or another are distributed unevenly and the resources value varies widely. Air photo interpretation provides a feasible means of monitoring many of the world's conditions. Tree species can be identified on an aerial photograph, so as also can the assessment of the disease and infested be carried out. The extent of which tree species can be recognized on an aerial photograph is largely determined by the scale and the quality of photographs. The characteristics of the tree form such as the cone shape, the branching habit are heavily used for identification on large scale photographs. Forest and wildfire example, for several years the number of fires in European forests have increased. In most tropical forests, a new category of forest fire risk have appeared in some region. Forest fires are a result of simultaneous existence of at least 3 unfavorable phenomena like long term drought, the effect of air pollution and high tourist presence in forest. Because of this situation, new techniques, mainly remote sensing and GIS technologies, have been applied for forest protection. High resolution satellite data such as Landsat, thematic map, SPOT, ERSR combined with low resolution satellite images such as NOVA, AVHRR offer new possibilities to monitor forest fires. They have a number of advantages over conventional means of observation. Like using satellite images, it is possible to view a vast expanse of land. This can be performed regularly for the same area and recorded in different wavelengths. Thus, providing information on the state of forest resources, satellite data can be acquired without encountering the administrative restriction. We can see that the remote sensing in forestry is very important because we can see the places that are damaged by people or the places that are cut from the space, and you can get these images when the satellite is passing above the region. We can also understand whether there is a fire, how big the fire is or where the fire is going without going to that place, and we can also take precautionary measures immediately. Forests have played a central role in economy, social and cultural development of many countries of the world. Forests were once seen solely as a frontier from which resources could be extracted. They now are viewed as many as precious lands that serve refuges for nature and recreation and act as a buffer against environmental degradation. This shift in the value has been most noticeable in terms of public forest. Effective management of forest resources requires reliable and timely information about the status and trend of the forest resources. In this regard, remote sensing and GIS play a vital role. New forest management priorities, however, have raised the question of whether these efforts, characterized by the use of ground and aerial observation and by the focus on vegetation measures, are evolving sufficiently to meet future information demands in terms of depth, breadth and timeliness. Application in geology. Geology involves the study of landforms, structures and subsurface to understand physical processes that create and modify the earth's crust. It is the most commonly understood as the exploration and exploitation of mineral hydrocarbon resources to improve the standard of living in society. Geological applications of remote sensing include the bedrock mapping, lithological mapping, structural mapping, sand and gravel exploration or exploitation, mineral exploration, environmental geology, geobotany, baseline infrastructure, sedimentation monitoring, event monitoring, geohazard mapping and planetary mapping. Applications in hydrology. Hydrology is the study of water on the earth's surface, whether flowing above the ground, frozen in the ice or snow, or retained by soils. Example of hydrological applications include wetland monitoring, soil moisture estimation, snowpack monitoring, measuring snow thickness, determining the snow water equivalent, ice monitoring, flood monitoring, glacial dynamics monitoring, river delta change detection, drainage basin mapping, watershed modeling, irrigation channel leakage detection and irrigation scheduling. Application in sea ice. The sea ice covers a substantial part of the earth's surface and its major factor in commercial fishing or shipping industries, Coast Guard's operation and global climate change studies. Example of sea ice information and applications include ice concentration, that is the ice type, age and the motion, iceberg detection, surface topography, tactical identification of leads, navigation, safe shipping routes, ice condition, historical ice, iceberg conditions, dynamics for planning purposes, wildlife habitat, pollution monitoring and meteorological change research. Mapping applications. Mapping constitutes an integral component of the process of managing land resources with mapped information, the common product of the analysis of remotely sensed data. Mapping applications of the remote sensing include planimetry, land surveying techniques accompanied by the use of a GPS can be used to meet high accuracy requirements, but limitations include cost effectiveness and difficulties in attempting to map large area or remote areas. Remote sensing provides a means of identifying the planimetric data in an efficient manner. So, imageries is available in varying scales to meet the requirement of many different users. Defense applications typify the scope of the planimetric applications such as extracting transportation route information, building facilities locations, urban infrastructure and general land cover, digital elevation models. Generating a DEMS from remotely sensed data can be cost effective and efficient. A variety of sensors and methodologies to generate such models are available for mapping applications. Two primary methods of generating elevation data are stereogrammetry technique using air photos, that is the photogrammetry, the VIR imagery, radar data, radar grammetry and radar informetry. Baseline topographic mapping. As a base map, imagery provides the ancillary information to the extracted planimetry detail. Sensitivity to the surface expression makes the radar a useful tool for creating base maps and providing reconnaissance ability for hydrocarbon mineralogic companies involved in exploration activities. This is particularly true in remote northern regions where vegetation cover does not mask the microtopography and where information may be sparse. Application oceans and coastal monitoring. The oceans provide a valuable food biophysical resources, serves as transportation routes, are crucial important in weather system formation and carbon dioxide storage and are an important link in the earth's hydrological balance. Coastlines are environmentally sensitive interfaces between ocean and land and they respond to changes brought about by economic development and changing land use patterns. Often coastlines are also biologically diverse intertidal zone and can be highly urbanized. Ocean applications of remote sensing includes ocean pattern identification, currents, regional circulation patterns, shears, frontal zones, internal waves, gravity waves, eddies, upwelling zones and shallow water bathymetry. Storm forecasting, wind and wave retrieval, fish stock and marine mammal assessment, water temperature monitoring, water quality, ocean productivity, phytoplankton concentration, drift, aquaculture inventory and monitoring. Oil spill. Predicting the oil spill extent and drift, strategic support for oil spill emergencies response decision, and identification of natural oil spillage areas for exploration. Shipping, navigation routing, traffic density studies, operational fisheries, surveillance and near-shore bathymetry mapping. Remote sensing data has proven to be an important tool in geography. The multi-temporal satellite data help in delineating the various change of Earth's surface. Remote sensing has progressively expanded applications in various fields. Because of its varied applications and ability to allow users to collect, interpret and manipulate data over dangerous areas, remote sensing has become a useful tool for all geographers regardless of their concentration.